Today we will learn basics about transformer. We have divided this lecture into two parts. Today we will learn basics about transformer, and the second we will learn about mathematics about the transformer and the details how it can be used. In the previous classes we have discussed electromagnetic induction, Faraday laws, electromagnetic force, then integral and differential forms, self-induction, mutual inductance, energy in magnetic field, and now we are moving to the application of these principles as a transformer. Today we will learn about basics of transformer and then ideal and real transformer. Before going into detail, first we will know the basic meaning of transformer. What is transformer? A transformer is a static device which transfers electric energy from one circuit to another through the process of electromagnetic induction. Is a static device means here nothing is moving. Transformer is a device and this transfer by some way electrical energy from one to another. In this transfer of electrical energy, we use electromagnetic induction. We have talked a lot about electromagnetic induction in the past classes, and you may refer to our previous lectures. Electromagnetic induction is a result of some variation in flux, magnetic flux. Whenever there is a variation in magnetic flux, this will result in the form of electromagnetic induction. We have used two terms here, step up or step down. We use electromagnetic induction to increase or decrease the voltage. Suppose you have a large voltage and you want to decrease the voltage for some applications. Then we use step down transformers. Or in other sense, suppose you have very small voltage, you want to increase the voltage, then you use step up. Both of work can be done either by step up or step down by the transformer. But the interesting thing about the transformer is it used to transfer electrical energy from one system to another system. I think many of you have seen, or all of you have seen, these transformers on the road, very big transformers. Whenever we pass in an electricity, we generate the electricity in power plants and hydropower plant, thermal power plant. Then we transfer this. When we transfer the electricity, then we use very high voltage to transfer. But when it moves to our homes, then we reduce it. So we use step down voltage to reduce the time. Again, there are certain devices in which we use very small. We need very small voltage, so we further step down. Sometimes you may also use step up for various purposes. The working principle of this transformer is very simple. Mutual induction between two or more windings, also known as coils. You have two coils, suppose, and the mutual induction between the coil allows electrical energy to be transferred. We have discussed this in the past lectures. We have two coils. In this, we change something in first coil. Now this will induce in the second, as we have discussed mutual inductance in the past lectures. Mutual inductance is very important to learn here. Basically, it depends on windings. As we have discussed, suppose you have two coils close to each other and you supply an alternating electric in one coil. If you supply one alternating electric source to one, this alternating current through the winding produce continuously changing alternating flux. If current is alternating, means the flux is also alternating. If alternating flux is there and you bring another winding, another coil close to this previous coil, then some portion of this alternating flux will link to the second one. And this flux is continuously changing. If the flux is continuously changing in its amplitude and direction, there must be a changing flux linkage to second winding of the coil. So that is important for us. Finding one variations is transferring into second variation. As we know from the Faraday first law, Faraday second law, that induction is there. If the change in flux is observed, this will result in induction. If an electromotive force is induced as per the Faraday law of induction in the second winding, and then the circuit of this secondary winding is closed, then a current flow through it. This is the basic principle of the transformer. Let us use electrical symbol to help visualize this. The winding which receive electrical power from the source as the primary winding on which we apply the electrical power. The winding where we use electromagnetic induction and we transfer, that is called secondary winding. The details are shown here. This is your source is attached. Now this source is attached with the first coil. The first coil is having winding. Since it is attached with this first, and mind this source is alternating. If the source is alternating, it means here the current is alternating. This will create flux, alternating flux. And this alternating flux is related with the second. And due to this is related with the second, and finally you will get here output in this. So this is due to induction. The winding which gives the desired output voltage due to mutual induction is known as secondary winding. This is the second coil in the diagram we have shown. The transformer that increase voltage between primary to secondary winding is defined as step-up transformer. Conversely, a transformer that decrease voltage between the primary to secondary is called step-down. Now we know this, how the voltage is more in first, how the voltage is more in second. It depends on number of coils, number of turns, length, and everything we have discussed in the last class. The diagram that we have shown in the above figure is called ideal transformer or theoretically possible transformer. It is not very practical because in open air, only a tiny portion of the flux produced from the first coil will link the second. So the current that flows through the closed circuit connected to secondary winding will be extremely small and difficult to measure. The current that flows through the closed circuit will be extremely small. This is really. The rate of change of flux linkage depends on amount of link flux with the second winding. So ideally, almost all the flux of the primary winding should link to the second. This is effectively and efficiently done by core type transformer. This provides a low reactance path common to both the winding. We will discuss these in detail, types of transformers and how it can be improved in the next lecture. First, learn about ideal transformer. What we have learned? We have learned then in ideally, whatever is applied to the first should be transferred to the second. There should be no winding resistance. There should be no leakage flux. The same flux should be associated to these windings. And there should be no iron losses, as the losses may be due to eddy current or hysteresis loop. Whenever you continuously alternate the current, there may be losses due to iron losses. Winding also have some resistance, because whenever you wind the things, it may have some resistance. So exactly transfer is not possible. 100% transfer is not possible. Some flux may be leak due to design or due to some other factors, and iron losses may be there. So no transformer may be practical, ideal actually. All the other transformer is called practical transformer that really exists. One may think, then if it is not possible to create, then why we are discussing? Yes, it is true, although it cannot be physically realized, yet its study provides information tool in the analysis of practical transformer. In fact, the practical transformer have properties that approach very close to ideal transformer. So thanks to all. Today we have discussed the transformer, basics of transformer, what is the principle of transformer, and the idea of primary coil, second coil, idea of ideal and real transformer. Whenever you want to discuss step up or step down transformer, we have to study the voltage dependence on number of coils, number of loops, so that we can get the idea and how voltage can be transferred. We will discuss these things in the second lecture. Thanks and take care.